I want to find c using the mean value theorem. Starting off the first example, we have f of x equals x to 2/3, and the interval we're interested in is 0 to 1. So for the mean value theorem, we're basically setting the slope of the secant equal to the slope of the tangent. Okay, so the slope we're evaluating at the endpoints, f of 1 minus f of 0 over 1 minus 0. And that's going to equal the derivative at x equals c. Now the derivative, we'll just use the power rule, bring down the exponent, and subtract 1. So now we're plugging in x equals 1 back to f of x. So that's 1 to 2/3, which is 1. And then 0 to 2/3 is 0 over 1 minus 0. F prime of c, well, I'm just going to take c and plug it in for x. So I get 2/3 c to the negative 1/3. 1 minus 0 over 1 minus 0 is 1. That's equal to 2/3 c to the negative 1/3. I'm going to bring the 3/2 over, so multiply both sides by 3/2. And here I'm going to flip both sides. So flipping will cause the negative to disappear in the exponent. And finally, I can cube everything. So I get c is 8 over 27. Now, whenever we find c, we should always make sure it's in the interval. So our interval was between 0 and 1, and 8 over 27 is definitely in that interval. So 8 over 27 is our answer. Next example is f of x equals x plus 1 over x. And this one is interesting because we get more than one c potentially. Okay, so our interval is between 1/2 and 2. So it's good to just get the derivative out of the way. And that's just going to be 1 minus 1 over x squared. Okay, so 1 over x, remember, is x to the negative 1 power. And then you just do the derivative and you get negative 1 over x squared. Okay, so now we're looking at the slope of the secant line minus the slope, equals to the slope of the tangent line. And for that, we need the endpoints. And we're going to plug in c in for the derivative. Okay, so first, f of 2. Well, if I plug in 2, I get 2 plus 1/2. That's 2.5. If I plug in 1/2, I get 1/2 plus 1 over 1/2. So that's 1/2 plus 2, which is 2.5. So I'm just going to write it as 2.5 over, well, 2 minus 1/2 is 1.5. Okay, so on the right side, we're going to plug in c in for our derivative. So that would be 1 minus 1 over c squared. 2.5 minus 2.5 is 0. Divide that by 1.5, that's still 0. So 0 is equal to 1 minus 1 over c squared. I'm going to add 1 over c squared to both sides. And then I'm going to flip both sides to get c squared at the top. So c is plus or minus 1. But remember, our interval, we said, was between 1/2 and 1. Negative 1 is not in that interval, but 1 is. Okay, so c equals 1 is our only answer. Okay, last one. We're given a piecewise function. It's x cubed if x is between 0 and negative 2. And x squared if x between 0 and 2. Okay, so for this one, we want to set, we want to find the slope of the secant line, and the interval here, they broke it up, but it's basically between -2 and 2. So we're going to evaluate f of 2 minus f of -2 over 2 minus -2. And that's going to equal the derivative at x equals c. Now the derivative is going to be tricky, so let's hold off on that. Let's first worry about the left side. So f of 2, well, I have two functions here. Where do I plug it in? Well, 2 is included in the bottom one. So plug it in for x squared, you get 4. -2 is included over here at the top. So plug it in the top. -2 cubed is -8. And on the bottom, 2 minus -2 will give us 4. And that's equal to f prime of c. Well, 4 minus -8, that's 12 over 4 is 3. So we're looking for when the derivative is equal to 3. Okay. But now we have to be very careful. We said f of x is a piecewise function. So that means whenever we take the derivative, we'll have to consider two cases. So the derivative of x cubed and the derivative of x squared. And the question is, okay, let's look at the first case. So the first case will be at the top here. This is the first case. If x is between -2 and 0, when is the derivative equal to 3? So the derivative is 3x squared. Set that equal to 3. You get x squared is equal to 1. So x is equal to plus or minus 1. Notice that we're in between -2 and 0. So positive 1 does not work. So x equals -1 does. And I should have put c here, actually. Technically, right? Because it's f prime of c. So c equals -1 works. Now in the second case, we're between 0 and 2. So we're setting the derivative in the second case equal to 3. And we get that x equals 3/2. And 3/2 is in that interval. So c is 3/2. So for this one, we get two answers. We get -1 and 3/2.